Awesome. And then so right before I pass it over to our speakers, I just wanted to mention that this session is recorded and it'll be available on YouTube directly after the broadcast. So I'll make sure after I stop sharing my screen, I'll share all the links to the programs that I shared. And then feel free to ask questions. So we're also moderating the chat spaces, so ask your questions there. And I think that's it. So without further ado, Vini, please take it away.
Thank you so much, Karen. That was amazing introduction with a lot of information. That's exciting. Hope it makes people who are joining excited to, just collaborate with us. So let me share my screen. All right. Awesome. So if you can see my screen, we are here in today's Tech Talk. We will provide an overview of Delta Lake OSS. My name is Vini Jaiswal, and I am a developer advocate at Databricks. I have been here since 3 years. Before that, I was working at Citigroup in the data science team, and I'm so excited just to talk anything about data. So joining me today is Denny Lee. Denny, why don't you introduce yourself?
Hey, thanks, Vinny. Hi, everybody. My name is Denny. I'm a developer advocate here at Databricks, longtime Brickster, working with Spark and Delta for a while. So here to answer any questions as well. That's it. Vinny, you take the show.
Awesome. Thanks for introduction, Denny. So we will start with what the Delta Lake is for those who are new to it, the pace of innovation in Delta ecosystem, and what is coming up in the roadmap in the next 2 quarters. We will wrap up the session with a few more callouts and ways you can be a part of this exciting journey. So please stay tuned. So with that, let's start with what Delta Lake is. So as you can see here, Delta Lake is an open source project that enables building a lakehouse architecture on top of your existing storage systems such as S3, ADLS, GCS, and HDFS. Some challenges where Delta Lake is used is around malinformed data ingestion, difficulties deleting data for compliance, or issues modifying data for your data capture. So your data can be from a variety of different sources, and it is either getting ingested as a batch or stream in the Delta Lake. In the diagram, I am presenting the Delta Lake medallion architecture. So in Delta medallion architecture, there are 3 tables categorized as bronze, silver, and gold. And the way to think about these categories are, first is ingestion table. That is where your raw data, which we call bronze tables, gets ingested. And on your raw data, you will perform some transformations for the refinement. So those tables gets called as silver table in this medallion architecture, which can be used for generating machine learning or AI models. And the third layer, which is gold layer, is where you have features or aggregated level data for BI or SQL analytics. So this end-to-end architecture called the Lakehouse allows users to run downstream applications of machine learning, AI, analytics, you name it. And here in this architecture, data only needs to exist once to support all your workloads, which makes it easy for data governance. So today, Delta Lake is used all over the world. Since you are all joining from different parts of the world, it can get you exciting. Over an exabyte of data per day gets processed on Delta Lake. And that accounts for 75% of Delta, that is Delta data that is scanned on Databricks platform alone. And Delta Lake has been deployed to at least more than 3,000 customers in their production lakehouse architecture. This project has come a really long way, and this is a snapshot of what the ecosystem of Delta Lake looks like right now. We will dive deeper into each of these. So in a nutshell, Delta Lake features are, it provides ACID transactions, scalable metadata handling, data versioning in form of snapshots, which provides ability to time travel. Data is stored in open format, and Delta Lake unifies streaming and batch processing. Further, Delta automatically handles schema variations to prevent insertion of bad records during ingestion. It allows you to audit history through transaction logs. Delta Lake also supports DML commands, including delete, update, and merge. And Delta Lake is fully compatible with Apache Spark API. So you can use the already known Apache Spark API to query Delta Lake. And these are some of the examples where Delta Lake is used for building lake houses. Chromecast saw massive performance gains, replacing 640 machines to 64, and reduced model deployment from weeks to 5 minutes. So Delta allowed them to do machine learning to petabytes of data from over 20 million devices, bringing personalized content to viewers based on their voice commands. Salesforce uses Delta Lake for their engagement activity platform. This is where like customers engage, and their engagement mutation job can now handle 25 million update delete requests within 15 minutes, which outperform their goal of handling 10 million mutations within an hour. That's awesome. And Script, they simplified the management of their data analytics workflows, significantly improving the development velocity and cross-team collaboration. The small file problem that plagued their engineering team was a thing in the past. With Delta Lake, they enabled performance optimized data pipelines. They saw huge reduction in operational and infrastructure costs, which equates to around 30 to 50% cost savings. That's exciting, isn't it? So let's take a look at the pace of innovation in Delta Lake. Today, we are at Delta Lake 1.0 version. It's been a long journey to get here. Let's take a look back at where we have begun and figure out how we all got here. So Delta Lake was first open sourced in April of 2019 at the Data and AI Summit. And that was the first version. That was pretty exciting. It included asset transactions and schema management, which was a huge improvement in the world of big data. It included streaming and batch, but we didn't stop there. We quickly added support for DML commands and vacuuming. We added Scala and Python APIs. And then we improved compaction and concurrency. It was made possible to convert Parquet files into Delta using SQL only. Other things that were added in the next version are things like describe history, which allows you to understand how your table has evolved over the past. This is why you can do time travel. In 0.7 version, we added the support for a whole bunch of different engines like Presto and Athena. And finally, a lot of work went into adding merge and other features in 0.8 release, and it hasn't stopped us from there. So the 1.0 release was certified by the community 4 months ago, and it was announced at Data and AI Summit. And you can see from this slide that there are a variety of new features that make it available, Delta available everywhere. So let's go through each of these features that got added. The first feature I want to talk about is generated columns. So what is the problem we are trying to solve? The problem that generated column is designed for is the one that data engineers are very familiar with. So you have a table that has a timestamp column, but you don't want to partition by timestamp column because that would result in way too many partitions. So instead, you want to partition by date. But to do that, you have to take a timestamp, convert it manually into a date, and you also have to tell your users that they need to manually add predicates to query both of these. This has some query computation implications as well. So you can now use generated columns to solve all this, and it is pretty simple. You just need to do addition of a little bit extra information. So in the code, you can see that I added a line called generated always us, and then cast event time as date. So Delta understands the functional dependencies between these two columns, and it would enable this date column to be automatically added. Pretty awesome. Another really exciting feature in Delta 1.0 is cloud independence. Now, what do I mean by that is Delta has always worked on a variety of storage systems. You could use it on Hadoop, you could use it on S3, you could use it on ADLS Gen 2, but with the advent of Delta 1.0 and the delegating log store, you can now have a single cluster that reads and writes from different storage systems. This is pretty awesome because it means that you could do federated querying across your data stored in different clouds Or you can use this for cross-region consolidation, taking information from all different places you think you have it and bringing it all in one place. And this, I think, is pretty cool feature because we have also been expanding the set of files that is supported by Delta. So we added support for Google Cloud and also IBM Cloud. And if you don't see your favorite one in here, stay tuned towards the end where we will tell you how you can get involved. Another feature is multi-cluster transaction. Delta Lake always had support for multiple clusters writing into a single table, mediating the updates with ACID transaction protocol, preventing conflicts. This has worked on Hadoop HDFS, ADLS Gen 2, and now Google Cloud Storage. However, users of S3 have always been left in the dark. It turns out that AWS S3 is missing the transactional primitives that is needed to build this functionality without depending on external systems. And this is why I'm excited to talk about a couple of initiatives from our open source contributors, the companies Script and Samba TV. They are adding support in the Delta transaction protocol to use Amazon DynamoDB to mediate between multiple writers of Amazon S3 endpoints. Now, multiple Delta Lake clusters can read and write from the same table. That's pretty cool. Now that we have got great Python support as well in Delta, previously we mentioned a few other things that were coming up in the roadmap, but yeah, with Python support now, it's important that it's easier for Python users to get started. There are two different packages depending on how you are going to be using Delta Lake from Python. If you want to use it along with Spark, you can just do pip install Delta Lake Spark, and it will set up everything you need to run job against your Delta Lake. But if you're going to be working with smaller data, or if you want to use pandas or some other libraries, you need to you don't need Spark to access Delta from Python anymore. You can just pip install Delta Lake, and this installs the native client for Delta based on the REST bindings. So Spark has always been closer to Delta project initiative. So Delta now supports 3.1. The Spark community has made a number of improvements around performance and compatibility, and it always is like doing so, right? And it is super important that Delta project keeps up to date with that innovation. This means that you can now take the advantage of increased performance in predicate pushdowns and pruning that are available in Spark 3.1. Another place where we did some pretty deep integrations is with SQL compliance. So it has now reached ANSI SQL compliance for DDL and DML commands like insert, merge, and explain. And finally, we are also integrating with the catalog APIs. And Delta Lake has integrated with those to ensure Delta tables are available for streaming that are available in the catalog so that you don't have to handle path metadata manually. So that was a lot. With the advent of all these features that we just walked through, Delta is now available everywhere you could want to use it. It's available from a variety of different languages. It's available on variety of different services. And there's connectors for all the popular tools for data engineers. And it is also queryable from many different databases. But it doesn't stop us there. We are innovating faster and we do want to do so. So now let's take a look at an overview of proposed deliverables for Delta OSS for the next 2 quarters. I hope you are with me so far. Cool.
You're doing great, Vini.
Awesome. So the first thing in the roadmap that I want to highlight is Delta Standalone. Previously, Delta Lake was pretty much a Spark project, right? As I mentioned in the previous slide, Delta wants to have a Delta project and Spark project were very close, which provides great integration with streaming and batch APIs to read and write from Delta tables. While Spark is integrated seamlessly with Delta, there are a bunch of different engines out there and a variety of reasons you might want to use them, right? Because we want Delta everywhere. So to support that goal, with the Delta standalone reader, we have created an implementation for the JVM that understands the Delta transaction protocol, but doesn't rely on the Spark cluster. This makes it significantly easier to build support for other engines. We already use the Delta standalone reader on the Hive connector, and there's work underway to build Presto connectors as well. And you will see in the roadmap, I will talk about different connectors as well. Also, given the demand for write capabilities, the Delta standalone writer seems like a natural next step to complete the Delta standalone ecosystem. So we are building a Delta standalone writer, which will allow developers to write to Delta tables without Spark. It would enable developers to build connectors so other streaming engines like Flink, Kafka, and Pulsar can write into Delta tables too. That's pretty awesome, right? So I will talk about what it does. With community's interest and excitement to expand Delta Lake and make it available everywhere, and with the innovation happening in the Delta standalone reader writer, this is how we are expanding a community. We are adding enhancements and a whole bunch of connectors to Delta Lake. So let me go through each of them. And again, like if you don't see your favorite one here, please engage with us on what you want to get added. So the first one I want to talk about is Apache Flink. For those who don't know, I will just explain about each connector. So Apache Flink is a framework and distributed processing engine for stateful computations over unbounded and bounded data streams. Most common types of applications that are powered by Flink are event-driven data analytics and data pipeline applications. I'll just take an example. If you are streaming a game or something, right? You can use Flink to do that. So in Delta roadmap, there's an effort around building a Flink Delta source. That is, Flink reads from Delta Lake using the Delta standalone reader. And with the upcoming Delta standalone writer, it can allow Flink to write to Delta tables. And there's an effort around a Delta sync connector for Flink. If you are interested, you can participate in active discussion by joining our Slack channel through Delta OSS group, which is Flink Delta Connector Slack, or through biweekly meetings. We are doing biweekly meetings on Tuesdays, so feel free to join. Second one is Pulsar. So Pulsar is an open source streaming project that was built at Yahoo as a streaming platform. In terms of Delta, we are bringing streaming enhancements to standalone reader to support Pulsar. There are two connectors which are being worked on. One for reading from Delta table as a source, and another is writing to the Delta table as a sync. So again, this is a community-driven effort, and there's an active Slack group. You can join us via Connector Pulsar Slack channel or attend our bi-weekly Tuesday meetings. Denny, feel free to add if you have anything.
Oh, sure, absolutely. So in the case of the Trino and Delta source, if for people are curious about it, what it boils down to is currently we're looking at PrestoDB right now more than the Trino. Nothing against Trino, by the way, just more. And so we're going to talk about that in a second. But because of the way the the way the code's forked. And so right now, if you are interested in chiming in and letting us know what particular features or what particular latency requirements you have, again, just like Vini noted, definitely chime in during the bi-weekly meetings or through our Delta user Slack. We're pretty active there, and we'd love to listen to and get your feedback. So, and later on, we'll also be asking for your feedback from a survey as well too. So, but yes, absolutely join us here because it's a very active project right now. And I believe we call this out in a few slides from now, but we're targeting at basically around Q3, Q4 timeframe to be at least to have a preview of this code base.
Awesome. Awesome. And for those who don't know what Trino is, it's an ANSI SQL compliant query engine off of Presto that works with BI tools such as R, Tableau, Power BI, Superset, and so on. And Yeah, so as Denny mentioned, Trino and PrestoDB are actively being worked on, coming from the same ecosystem. Presto is an open source distributed SQL query engine for running interactive analytic queries. So we are also working on getting a Presto Delta reader to allow Presto to read from Delta tables. So the channel for that is Connector Presto, and you can join our biweekly meetings on Thursdays. And then Rust. So it gets me excited. For those who are new to Rust, Rust is a programming language that helps you write faster, more reliable software. If you want to learn more about this language, Tyler and his team has written an amazing book. In terms of Delta, Delta-RS is a library which provides low-level access to Delta tables in Rust. So native code for working with a Delta makes it easy to use your data from a variety of languages. We now have Python, Kafka, Ruby, and Go support using Rust bindings. The Rust implementation supports write transactions, and the work is underway to productionize Kafka Delta ingest. What it will do basically is, like, if you have data coming from source systems through Kafka and it is being ingested into Delta Lake, in the Rust, you can write the whole workflow and you just don't need to have like manual configurations done. You can just do it in code and it simplifies the operation. You can learn more about this in the upcoming Tech Talk, which is scheduled for October 7th, where the script team will dive deeper into Delta Rust. And again, engagement channels are Delta-RS Slack channel, and we also have bi-weekly Tuesday meetings where you can join us. Awesome. Now let me talk about Nessy Delta integration. So there's a tighter integration coming up in between Nessie and Delta to allow for Nessy's Git-like experience for data lakes that can work with Delta Lake directly. And this is again a community effort, and all are welcome to join Nessy Slack channel. And we also have bi-weekly meetings on Tuesdays with Dremio. LakeFS is an open source tool that transforms your object store to Git-like repositories. It enables you to manage your data lake the way you manage your code. So we are working on a very tight integration between LakeFS and Delta to allow for experience for data lakes to work with Delta Lake. For this, the channel is LakeFS. You can join that channel, or we also have bi-weekly meetings coming up soon. We will post it there. And then Hive to Delta connector. This currently exists as a library to make Hive read Delta Lake tables. So we are updating the existing Hive to connector, just like Delta standalone reader, so that we can support Hive 3. And then Apache Spark, right? We have seen great pace of innovation in Spark. And with that, as I mentioned before, we want to keep the innovation happen with the pace of innovation at Spark. So there are two main things coming up in the roadmap. We want to provide support for what Spark is offering, which is support column drop and rename commands, and then support Apache Spark 3.2. So that were like exciting announcements on connectors. So putting it all together, we reviewed how the Delta community is rapidly expanding, and we have connectors planned in the roadmap. Here's the screenshot where you can see when is the connector coming, and if you don't see any connector in the list, if you have any requests, please let us know. Okay. So another project underway that I want to talk about, gets me excited, is Delta sharing. There's a growing demand for ways to share data that is beyond the walls of the organization. For example, what if you want to share your data with external entities like partners, customers, whatnot? Users sometimes are frustrated with the constraints on how they can share their data. Think CSV files, file size limits. And once that data is shared, version control and data freshness are so tricky to maintain. Let's take an example. Take a group of data scientists who are collaborating. They are in the flow, they are in the rhythm, and on the verge of getting an insight, they suddenly realize that they need another data set. So they submit a ticket and they wait for maybe like few weeks. So in the 2 weeks or so, it takes them to it takes the rhythm out. It takes so long to get the data access. So the time is lost, conditions change, and they lose the momentum of that insight. Data sharing shouldn't be a barrier to innovation. This is why I'm excited to talk about Delta sharing, which is industry's first open protocol for secure data sharing, making it simple to share the data with organizations, regardless of what compute platforms they use. And to illustrate how this works, let's look at under the hood. So let's consider this example of data recipient getting most recent sales data from a data provider. When the data recipient requests to read the sales table from the data provider, they send their authentication credentials to the Delta sharing server where access permissions are held. Permissions for the authentication credentials are then checked against access granted in the Delta sharing server. These access permissions are then translated by Delta Lake to identify if the pertinent underlying Parquet files exist, and it identifies it. Since permissions may be specific to a subset of the table, Delta Lake applies the permission to find only those files which the authenticated credentials have access to see. Then Delta sharing generates short-lived sign URLs to read the files and transmits these back to the data recipient. The data recipient uses these sign URLs to directly access the data files from their cloud storage location. And this Delta sharing uses an open format so that it can allow external programs and clients to access data. With Delta sharing, not only you can share data, but you can also share machine learning models as assets with other users. Pretty exciting. So we are really excited about this ecosystem that started to build around this already. There is a lot of interest, and we are releasing connectors with a whole bunch of projects, and community is already writing some as we speak. We are also seeing many of the leading commercial vendors in data management, business intelligence, and analytics vendors, as well as digital native companies supporting this as well. With that, I want to highlight this quote from one of our project committers, now a beacon. Karen will share more about the beacon, who says, with Delta Lake 1.0, Delta now is ready for every workload. With this message, I want to emphasize the importance of having these amazing contributors, without whom this journey would not be easy. This is why we always look for community participation. So while we have exciting momentum going on in the community, I want to encourage you to get involved. If you haven't already been, there are a bunch of channels on how you get involved with us. Check us out on Slack, check us out on YouTube channel where you can find this video or another video. There's a mailing list. If you want to get involved with the actual code, you can also join us on GitHub and more. And yeah, I would like to call out the survey. Do you want to kick this off, Denny?
Absolutely. So for everybody, thank you, Vini. You've done an amazing job. By the way, for all the folks who are asking questions, keep on asking them, and we'll probably answer some of them live anyways, because they're actually worthwhile for us to answer live. But just keep on answering questions, just because we know we've packed a lot of information. So thank you very much, Vini. Now, specifically to the roadmap survey, the implication of what Vini's talked about is exactly that. There's a lot of things going on with integration, right? There's, again, whether it's LakeFS or Nessie or Trino, Presto. So we would love to get your feedback on that. We'd love to understand better from you, the community, Delta Lake community, what is important to you and how should we prioritize these things? We do this at a roughly 6-month cadence. So it doesn't mean we don't listen to feedback, by the way, between the 6 months. We absolutely do. We just sort of formalize it every 6 months. And also, honestly, I don't think my management's going to let me give out t-shirts more often than every 6 months. Okay, so just shout out to Ryan. I'm probably in a lot of trouble already, as it is. So please do fill out the survey. The link's there. The link has also been submitted to YouTube, Zoom, and LinkedIn. So you all can chime in there, so you don't have to copy paste that. if you've already filled out the survey, and I'm going to blame myself on this one, that's why Vinny made sure I actually had to go ahead and call this out. Can you go ahead and log back in and fill out the survey again? Not all of it. We've kept everything, but I forgot to ask for your address in order to send your t-shirt. So my bad on that one. So if you've already filled out the survey, please log back in and add in your address information if you still want the t-shirt. If you don't, but did indicate, we will email you for that information anyways, but just to simplify things, if you can do that. So yeah, my bad on that one, but please, this survey will be open at least till we extend it a little bit further since we're getting a lot of excellent feedback, but we will shut the survey down by I'd say mid-October. So we'll announce that out, by the way, at the very latest. So please do. You get a free t-shirt at a minimum, and also get a join in a raffle for the edition of the O'Reilly Definitive Guide, Delta Lake's the Definitive Guide from O'Reilly. By the way, 2 of the co-authors, you're talking to them right now. So there you go. So that was also just a little bit of a call out for us. Haha. Shameful plug, basically. All right, that's it for the roadmap survey. Back to you, Vin.
Awesome. Yeah. So I think that's all I had in the slides. We would love to see questions, and then, we want to give it out to Karen. All right. So let me stop sharing, and then we can see some questions.
In terms of questions, basically, how about this? Why don't I go ahead and chime in some of the questions from LinkedIn for starters, okay?
Yes.
Okay, perfect. So actually, Mike from LinkedIn actually had an excellent question, which is basically, if you're implementing Delta Lake on an existing data lake, is there an impact on data flow speed, or is it not noticeable at all? And so if it's okay, I'm going to take this, I'll answer this particular question, okay? And so, Mike, for starters, excellent question. I did actually respond to LinkedIn already, but I figured I can also add a little bit of color to this. So first of all, when you're talking about Delta Lake, it is a storage layer. So there's not a processing engine that goes with it. So it's not like there's anything inherently about a storage layer that allows us to go ahead and speed things up on a separate decoupled processing engine. Saying that, ultimately, there's a lot of things that have to do with the file system. So with the way Delta Lake works is that we can do things to structure the file system so that way the process engine, whether it's Spark or any of these other systems that we were talking about here today, they can go ahead and read these things significantly faster. Now, in the case of, for example, I'm going to use one simple example. When you're using cloud object stores, there's a lot of files. The listing of those files actually is extremely slow. For example, if you're writing in your computer doing you're doing an LS, listing of the files. On your local computer with an SSD, that's actually really fast. On a cloud object store, that's actually quite slow. So in that particular case, that actually would be extremely non-performant, very slow. In the case of Delta Lake, that information is actually stored in the transaction log itself, the metadata there. And because it has that, it's actually able to read the list of files directly from the transaction log. And then your distributed system like Spark can go ahead and actually send out multiple tasks to go read for that data. And so things like this help optimize the performance of your system. So it can be quite noticeable. Now, in the case of open source Delta Lake, for example, I'm going to call ourselves out. There's been asked for us to implement an open source version of Optimize, okay? So that's not currently on the roadmap, but if you join the GitHub issues, that's what people are asking. So right now we are currently examining what are the right approaches for us to do that. Optimize currently is a Databricks feature, not an OSS feature, but we listen to the community and we are trying to figure out what's the right way and the timing for us to do that. Optimize allows us to ultimately though, restructure the files in a slightly different way to basically go ahead and improve the performance that even more so. Not so much because of, again, we're not affecting, Presto or Trino or Flink, or Spark, we're not affecting those engines, but the structure of the data is optimized even more with additional indexes and things of that nature that will ultimately help improve performance. So hopefully that answers your question, and hopefully to provide context, hopefully that answers, provide a little context on why it's so important to actually have something like Delta Lake in order to not just ensure the reliability of your data, but also improve the performance of your data. Okay, hopefully it helps. Cool. Any other questions that are chiming in? I don't think I see any on the the Zoom chat.
I think there's a question I'll read out loud. I would like to know the difference of a traditional data lake plus SQL Server plus other cloud services versus the lake house. I can try attempting that question, Denny.
Please go for it.
Yeah. So the difference from traditional Delta Lake SQL Server cloud services, you nailed it. It's not a difference. Lakehouse actually is an umbrella where you can fit in Delta Lake. So you have your data lake. Lakehouse doesn't have to be on Delta, but Delta just provides reliability and performance to your data set. So you can use, you can have data lake, you can have machine learning, SQL Server on it, and other cloud services. And the whole architecture is called Lakehouse. Hope that answers your question, Luis.
Yeah, and actually, let me chime in just because that particular question happens to hit me in the heart a little bit. So the reason why it hits me in the heart is because I actually used to be part of the SQL Server team. Okay, so many eons ago, I was actually part of the SQL Server team to build databases. I also was on the team that built what ultimately was now known as HC Insight, Hadoop on Windows, Hadoop on Azure, and then obviously we switched over to Linux because that's obviously a smart thing to do. But the reason I'm calling that out is because when you're talking about databases like SQL Server, they are a single system that are hard to distribute. And ultimately, you could try to distribute them by basically sharding the database, but that becomes a management overhead that becomes excessively complicated. So, but databases, to their pro, have ACID transactions, right? And so in other words, they ensure the reliability of your data. With the V2, that's the V1 of the data engineering world. We started with databases. The V2 of the data engineering world is for us to say things like, okay, let's just do data lakes. And I was guilty of that, by the way. You know, it's like we just shove everything. And as Vini alluded to, it's like it very much is this concept of great, we store everything, but it's garbage in, garbage out. Okay, so if you store garbage, you're going to get garbage, right? And so why? Because it was lacking that reliability. It was lacking the idea of ACID transaction, schema enforcement, things to ensure that the data actually was good, which is what we cared about in V1. Okay, but V2 we wanted that flexibility, so that's why Hadoop and data lakes in general became so prominent. So now V3 is of the data engineering world, this idea of a lake house, right? The best of both worlds, right? We constantly do these things, best of both worlds, right? And I'm sure there's a Star Trek particular theme that I could throw in there, but I won't digress too much. But the context is we want to take the ACID transactions and that reliability of a database, but also give us that flexibility with a data lake. And then that allows us to build that lake house that you so desperately need, okay? Because in this world, as we progress and have more and more data, ultimately that's what you actually need. You need the melding of those both worlds. So as a SQL Server guy, like I said, I was part of the SQL Server engine team, right? As much as I love that database, this new world really does require us to shift over. I'm not trying to bash SQL Server, quite the opposite. There's still many scenarios where databases themselves are extremely useful and you should use them. But when it comes to the flexibility and the sheer volume and the fact that you're trying to do machine learning, data science, AI, streaming, all of these other data domains all at the same time, that's the reason why it's so important to make that shift to the lake house. And fundamentally, Delta Lake is required for that lake house to work. I'll get off my soapbox now.
That was really passionate answer, Denny. Love it.
Thank you. Let's see. The next question is easy one. Unfortunately, because it's short. Do we plan to put any SAP connectors in the future for Delta Lake? We don't have any plans for that right now, but that doesn't mean we can't do it, by the way. In other words, this is why we want community feedback. So while I'm giving you the answer, we don't have any feedback on that. If you chime in the survey, or if you chime in, so Delta's user Slack, and we get enough feedback from the community that you're interested in working with SAP connectors, and then exactly what type of SAP connectors you're talking about. You're talking about HANA, you're talking about the ERP systems, what's the nature of those connectors. Then yeah, it's not like we're against the idea of doing it. It's just that up to this point, at least, the community hasn't asked us to go work on that. And don't forget, it's not just like individuals like, that are like going to go do this. We as a community are going to work together to go build these things. Any other questions you can think of that are worth talking about?
I think there is one question about data skipping statistics in Apache Spark. So will you provide
Sure.
data skipping statistics in Apache Spark equivalent to those in Databricks runtime?
Okay, I think the question here is basically adding column stats. Right now, we don't have plans to do it yet, just because of the nature of the way the column stats works within the Databricks runtime. If there's a concern from a performance perspective, definitely chat with us, because in fact, we have very good details and evidence of the fact that the performance even on Delta OSS is actually quite fast without those column stats. It doesn't mean we're not interested in doing, by the way, it's just that it's going to take us a longer time for us to delineate what we've done for the Databricks runtime and what is applicable and better for the community as a whole. So that's the only reason why I'm calling that out. So.
Yeah, and one more thing I would add is like collecting, if you have like long strings or something, collecting statistics is expensive operation. So you can either configure the table properties, to avoid columns containing long strings. But yeah, eventually, like if you have any requests like this, we would love to get it on the survey.
Oh, perfect. There's a great question that just followed up that just came from Kaushik from LinkedIn. So what does it take to realize an idea from the community to actually put it on the roadmap? Great question. Okay, so here's exactly the approach and that you want to go do. For number one, obviously, fill out the survey and work with the community, whether we're talking the Delta users Slack channel or the Delta users distribution list. Saying that, okay, that's obviously you want to get involved with the community. Don't forget, the other key things is to actually create GitHub issues, okay, and chime in that these are things that you want to see. The reason, for example, we chose the issues list that you see, like right now that Vini just presented, it wasn't because we just randomly chose them. I mean, I'm sure there's one or two that we did, but in reality, that's not how we chose. What we chose is based on the feedback we got from the community. And so how do you get feedback from the community? Create a GitHub issue and then chime in there. Now, we often will get feedback directly from people as well. And so that sometimes it won't be very obvious. That's why, for example, there's this feedback of Presto and Trino. But that's also part of the reason why we created the survey, which is like, we knew we were getting feedback directly that wasn't necessarily from GitHub, but we wanted to, before we did all these things, we wanted to go ahead and chime out and ask the community for their input. So that way we can figure out how to prioritize accordingly. So if we don't want to go through that route, yeah, create a GitHub issue and then get other community members to chime in, to vote for it, to actually say, yeah, we see that this is important. And then that's actually how you get it on the roadmap, because this is a community effort. So really, definitely join us in the Delta Lake. Again, the Slack channel is probably the best way, because we're a lot better about answering that more than anything else. But whether it's that or the user groups, they're all the same. Please go ahead and chime in. And as Vini also called out, for a lot of these integration efforts, for example, we have bi-weekly meetings as well. So if you chime in on there too. So lots of really good stuff for you to provide your input, provide your feedback. And of course, we're always looking for contributors. So if you're ready and willing to write code, absolutely. we're ready to hear you from there too. Cool.
Yeah, and I also.
Go ahead, Karen.
Sorry. On that note, I was just going to say too that I, in the YouTube link, I have a link to join the Delta Lake Slack and a few other links too for more information. So, so it's easy for you to join and start contributing.
Yeah, and we regularly post updates, so you can follow Denny, me, and Karen on LinkedIn or Twitter. So you can get exciting updates. And also, like, if you want to have hands-on coding and contribute to our code base, you can follow us on GitHub. So we regularly have active discussions going on. So please do that, and you can get to know what features we are releasing before we even call a bigger event.
And I actually just launched, that's actually a perfect segue too. So I just launched a poll in Zoom. So sorry if you're on YouTube or LinkedIn. I launched a poll. So we were thinking about maybe trying out doing a virtual Delta Lake hands-on workshop. We'd kind of have to tweak it and see what would make sense, maybe an hour or so session. But the poll's just if you're interested. If you're interested, we can send you more information when we kind of flesh out the idea a little bit more. So feel free to post in the chat too on LinkedIn and YouTube if that's something you'd be interested in.
Awesome. There are a lot of good responses. We want to see more. Come on. Prasad, I see your question on Delta Rust finding. Join us on the channel and we can help you for fully resolution on that. Yeah.
Yeah, I was about to chime in. Looks like since we're wrapping up right now with the poll and all these things, our apologies to everybody who we have not been able to answer questions. It's not lack of interest. It's just lack of time, I guess. So please do join us on the Delta Lake users Slack channel. We are, whether it's Vini and myself, but also various other engineers, we're all there to answer your questions. And so obviously we're doing it asynchronously, so we may not be able to get to it right the second, but the point is that we definitely are there to answer questions. So please be comfortable to ask your questions there. We have lots of different channels to chime in. And for that matter, you can always tag me and I'll do my best to answer your questions as soon as I get enough coffee in my system. So there you go.
There's another question from Chris. I think it's along the similar lines of how people can get engaged if they haven't contributed to open source previously. So what we will do is we will share the slides, or these recordings are available, and there are different ways you can join us, either on GitHub, or maybe you can join us through different channels for different projects. And we can show how you can engage with us.
Awesome. So I think with that, so it looks like about 50% of the folks in Zoom have answered my poll question. So that's awesome. Looks like most folks would be interested in a hands-on workshop. So we'll go ahead and start planning something, which I think will be cool. We haven't done a workshop kind of style online event before, so that'll be cool to do one about Delta Lake. So awesome. Thank you everyone so much for joining and for all of your questions. And thank you so much, Vini. Loved hearing about what's coming up. Excuse me. And of course, Denny, always a pleasure. So with that, everyone, I hope you have a great rest of your day and take care.
Yeah, thank you all. Bye.
Take care, everybody.